so cold. If we want to cool it, we just put ice on it. In this video, I want to show you all the improvements I made from last try. Friction. Scratch here. Where it didn't work. Then I want to show you how I try to make it run. I also have some comments from the last video I want to talk about. I had one comment from David Coates. He suggested to lower the compression, about some improvements I could make. And I also want to measure this thing. I want to know the dimensions. Volume is 280. It will be a pretty long video, so just skip to the part you're interested in, or of course watch everything. Thank you. Yeah, one more thing. If you don't like my video, let me know in the comments what exactly you didn't like, or just make a better one. Thanks. Okay, last time the Stirling engine didn't work. It nearly worked. This time I have some improvements. I read some of the comments. You mentioned the cold side. I should cool it. I think that's not the problem, but I have a cooling head. I made a cooling head anyway. And also I bought some heat tape. I will bend around, I will wrap around the hot cylinder so that the heat cannot escape. Also I will turn around the hot side so the heat always goes up, so the heat will stay inside. I read something about the heat expansion. So if you heat air by 500 degrees Celsius or Kelvin, or the expansion factor is about 1.8. So I heated, last time I reached 500 degrees or 530. So if you have 1 cubic inch of air, it will expand to 1.8. But if you heat it to 1000, it will expand to 3.6. So we will try to get it hotter this time. Also, what I will do right now is I will test for leakages, because last time I saw when I heated the cylinder, some bubbles came out here. I'm not sure if this thing is airtight or not. I will check right now. This is soapy water. I will spray everywhere. Let's check in detail. So no leakage, that's a good sign. Then let's dry it out. So right now I will disassemble it. I want to check if the piston did some damage to the cylinder wall on the hot side. Sounds okay, but also I want to check how many piston rings I put on there a couple of years ago. Maybe I will remove 1 or 2 piston rings to reduce the friction. Okay, we have some debris inside. I think this is, I'm not sure, this is aluminium, yes. You have a scratch here. There is a scratch, but I think nothing major. Slight scratch here. This side looks good. Scratch here. I think not a big problem. Okay. Okay, that's what I thought. We have 3 piston rings. I will remove some. I think I will remove one on the cold side, because the cold side gets, I think the cold side is not the problem. I will lubricate this side, and I will remove, I think, 2 on this side. Let's see. Okay. So that's that. Okay, I will remove the first ring and the second ring here, and on this side I will remove the middle ring. Okay. See, here's the pin. Okay, we have that. I was thinking about lubrication, and the only thing I could come up with is graphite. I don't have any graphite lubricant spray. That's why I will just use what's the name? I will just use a pen. Okay. I brought this one. I will smooth out again. It will not change the diameter, I will just smooth it out. It is nearly the size. See, it's nearly perfect again. There is one scratch here, but other than that, not a big problem. I will also put so this is the this side has no problem, no need. So we will put back, oh no, I wanted to remove one ring. Let's mark the pins that I don't have to check for it. Pin is the pin. Our pin is here and here. Okay. So let's put this back on. I don't know if you can see it. Cold side. A little bit of grease. This is also done. So we can put this back in. Check the friction. Okay. So you can see it's running free. Friction is not too bad. Okay. I had this one planned to go over here, but I couldn't manage the time to, I couldn't find the time to put it on a lathe and put over just for cooling. But I prepared this one. We will smoothen out this area, and we will put on the cold side. We will put on here like this. Yes. Then we will put on this tape here. see. So we have this. Then I always wanted to check how it looks inside. I never checked for years. Maybe steel wool. I want to know how hard it is to blow through, how big the resistance is. No, that's okay. I think we can put more inside. I will replace these screws because they are too long. Let's check for a shorter one. Yes. Or maybe we just take a few washer. Should be enough. I'm gonna put this thing on like this. Better like this. Oh, let's do like this. Let's do like this. Therefore, I have to mark the position. Seven millimeter. Okay. take off a little bit. Okay, last time it was not running. This time we made some improvements. The heat shield here, which will keep the heat inside. We made the cooling head on top. We put additional steel wool inside. What else? We took out some piston rings to reduce the friction. We lubricated the cold side with WD-40, and we lubricated the hot side with graphite. Yeah, I think that was it. Let's put the shield on. It's a bit wobbly, but doesn't matter. So again, we will test the maximum speed, maximum rotational speed with the drill in cold. Then we heat up, and hopefully it's running. If not, we test again the speed. Let's check again. Okay, I read 260. Meanwhile, now it's 217. Slower than last time. I'm not sure. Maybe it's because compression is higher, or the battery. Yeah, battery is also not full. I read 260 maximum. Let's see if we heat up the thing. Yeah, I was thinking about additional cooling, but today it's so cold. If we want to cool it, we just put ice on it. So yeah, no need today. Cold side 1 degree, 300. We need more heat. side 20 degrees. And warm, maybe 30 degrees. Okay, I think I saw it running 1 or 2 rotations. I have to rewind the video. Heat sheet melted. Cold side temperature was around 30 degrees, so this is okay. I think this is not the reason. On the hot side I could read this time 670 degrees. Yeah. And in the end my bolt broke, so it's stuck. I'm not sure if I will repair this thing or if I will put it to scrap. If any of you have an idea what could make this thing run, please let me know. Okay, so in this part I want to do 2 things. I want to react to some comments from the last video. There were some good comments, and I also want to ask some things, maybe one of you knows. And in the second part I want to dismantle it and check some measurements. I want to know the displacement of this thing, how big the diameter is, the piston diameter, and also the cylinder diameter. Yeah, so let's do that and start with the comments. I had one comment from David Coates. He suggested to lower the compression. Yes, I heard it several times in the comments, but my thought is, if I lower the compression, what should I benefit from that? So I know it's hard here to reach one point, but after that I get the energy back if it's over the point, so it equals out, I think, in my opinion. So there was another comment, we come to it later, just make your flywheel bigger, so then the engine gets over the hard point with the energy from the flywheel and can make it one rotation. So this might be one solution, just increase the flywheel weight. Then it will pass the hardest point and it will run. Okay, so so the first one was lower the compression, so I don't really get it unless you explain it to me. Maybe I can understand then better. Next one is from Di Guerrero. Yeah, he said cool the cold side. So I put a cylinder head on right now. I think it's just for fun. Looks a little bit better, but the impact is not very high. And even when I measured, the cold side is around 30 degrees. So I think the heat difference from both sides is enough, in my opinion. Yeah, I don't know the air temperature inside, but from the cylinder walls and the head temperature, the cold side is cold enough, I think. Okay, next one is from Pneumatic Grunt. Yeah, he said this one was a good one. I should heat the walls because the surface area is not big enough. So the heat cannot be transferred within such a short time because the surface area is too low. I also was thinking about this already before I built this one. This was the reason I had an invention in mind, and that's why I built this engine in its original form. Then I wanted to put in my invention, which would have increased the surface area on the hot side and also on the cold side. And with that, I could have done that even without, yeah, I will come to that later. Good idea. I heat the cylinder walls. Right now I just I put a heat shield on, so the air is somehow trapped inside. That was my thought process. Yeah, it's maybe it's a good idea, but yeah, it's hard to do, to heat from all sides. Yeah, good idea, pneumatic grunt. Next one is from Bart Pediator. He said the compression ratio is too high. The heat transfer area is too low. That's right. That's the point. Yes, we already talked about. And he said I should lower the compression by inserting some pieces between cylinder and cylinder head, so that there is a in the top dead center of the piston there is a spacer to the cylinder head, so that there is still air between cylinder head and piston. I don't really get this point, because in my head, if the volume increases, it's dead volume for me, because the piston is not reaching the top. And that means for me, if there is too much dead volume, I will not push all the air over to the other side, because yeah, on both sides we have dead air, which is not going completely over to the other side. If I increase it here by, let's say like this, I will just push air until maybe here, and it will not even reach the cold side. So that's why I don't really get this point with the lowering compression. Please explain to me what the lowering compression should bring to this motor. But as I said, I'm not an expert. I read some books 10 or 12 years ago. I forgot most of it. So please explain. I can't remember. Or yeah. Next one. I am sick. Said lower the friction. Yes, we lower the friction. I think friction is not even a big problem anymore, but one idea could be to take out all the piston rings. Maybe that could be one last try. If we take out all piston rings, then there should be no friction at all. Of course, then some air will leak through on the side walls of the cylinder, between piston and cylinder wall, leak down and go into the housing. But at least, yeah, it could be one worth a try. Yeah. Yeah, he also said spacers on the cylinder. Yeah, that same point like before, we would increase the dead volume. I don't get it, but yeah, please explain. Next one is Saro Kota 86. Compression down, put in a valve. I'm not sure if I 100% get his point, but if I would, for example, add a valve here, which will leave some air out, that don't really make sense to me. Doesn't matter where I put the valve, put it here or here. Then hot air would leak outside, cold air would leak outside, then the whole principle of this motor wouldn't work, I guess. Yeah. Okay, next one. Yeah, he also said put lubricants on it. Yeah, we already did a little bit. On the cold side, you can put oil on, no problem. On the hot side, I would need, I guess, graphite oil or something like that. I put some pencil stains there. Yeah. Okay, then Taser Games said you should put a flywheel with fins on. Yeah, I think this idea. Thank you anyway for this. But flywheel with fins, I think with the thermometer, we already saw the heat is not the problem, the cold side is not the problem. It wouldn't do too much then. I think the impact would be marginal. Okay. Last one is Ali Reza. He said cool to 25 degrees. I think he means the cold side. It is nearly 25 degrees. The hot side this time was 650, 700 degrees. So the difference is big enough, I think. I read somewhere when you put in when you increase the temperature by 500 degrees, the air, which was an original 1 cubic inch or cubic centimeter, becomes 1.8. If you increase it by 1000 degree, it will increase double to 3.6 then. So one way would be one way to improve the efficiency would be to make it hotter, but then you have the problem with cylinder walls and aluminium nearly melting, or diameters will change. So it's hard. I think it's nearly on the limit. Maybe 800, 900 degrees possible, but then you get a problem, I think. Yeah, that's it. Give me your ideas. Maybe, yeah, one last thing. My thought was, because all of you said, or many of you said, lower the compression. I thought maybe the volume, or this thing here is the absorber. It buffers the heat, or it is saving the heat. And if I would increase the diameter of the tube between, I could put in more steel wool, so I had a bigger buffer, heat buffer, and also the compression would also shrink, because then I have more dead volume, more air can be compressed easier. Yeah, so that might be one idea, and would be relatively easy to make, just to make some adapter here and bigger tube. Might be one idea. Yeah, the other one with increasing the space from top dead center to cylinder wall, also not too hard. Just put some spacer plates. But I don't really see the point there to increase the, or lower compression. Why should I do that? I don't get it. Maybe if you have some formulas how to calculate how much steel wool, or how much material you need to save the energy, or yeah, then let me know. Maybe I made some wrong calculation. Okay, but now I want to know how much the stroke is, how big the stroke is, and how big the cylinders are. I want to know the ratio between stroke and diameter, and also I want to know, the displacement. I think displacement we need, because it's a 90-degree angle. I think you can calculate it by this side, when this is in top dead center. No, not top, no, not bottom dead center. So we have the air here. Then this one is somewhere in the middle. I will measure and then add the volume from this side and also this side, and then I think I have the displacement. Not sure if that's the correct way for Stirling engines, but this is the air then, the active air, maybe plus the buffer size. Yeah. If you have good formulas which could help me improving this thing, let me know. Yeah, I'm not really sure if I will continue. Now also the bolt broke here. Yeah, let's just measure the thing. .33, so probably inside around 30 millimeter times 114, 113, 114. .9, let's say, and we have a stroke of 1.7. The bottom dead center 72.5. Yeah, I use the calculator. The volume is 287,462.315 millimeter cubic millimeter, and this is three dots to the left, so this is 387.4, let's say 5 centimeter cubic centimeter. This is for one side, so both sides have a displacement of around, oh, this is 290, so this is nearly 600 cc. 600 cc, so this is like a bicycle, no, like a motorcycle engine actually. Yeah. I just needed some number for my thumbnail, for the title. Sounds better, huh?